So good afternoon. Thank you so much for being here. I know the conference is wrapping up and you guys getting ready for kickback party tonight, but I appreciate you guys being here. So let me start with a simple idea. Can AI generate answers? And as we all know, yes, surely at this point, AI can generate answers. But honestly, that's not the problem anymore. The real question is, are those answers right? Because in healthcare, in finance, in any regulated environment, almost right is completely wrong. Most systems today go from raw data to RAG, retrieval augmented generation. What I'm going to show you today is how we go one step further, so from RAG to write. So remember the triple R, raw, RAG, write. So here, how we're going to spend the next 30 minutes, we're going to start with the evolution from predictive AI to generative AI. So then I'm going to talk about why isolated large language model fails in enterprise settings. And after all, we're going to talk about the architecture, how RAG works with SAS Viya. And finally, I'm going to show you some real world examples and show you how we move from naive system to the trusted one. So the evolution is easy, it's fast, fluent, fluctuated. For years, SAS has been gold standard for enterprise analytics. You can run a procedure like prog means, as you all know how to run that. So surely you get answer which you can trust it. And you get result which is deterministic, verifiable, defensible. That was the word of classical predictive analytic. Then generative AI comes. Suddenly, we could ask question in plain language, and then we get some answer. It felt like a breakthrough, but here is the problem. These systems do not understand the math behind it, and what they are saying, they cannot verify numbers, they cannot check their own answers. They sound intelligent, but they are grounded. And the data marks this clear. Unvalidated Gen AI system can produce error rates, which is around 18%. So think about it. Nearly 1 in 5 numbers could be wrong. In output that is exactly looks professional, it could be wrong. So now we need a third stage, factual AI. And here is the key idea. Fluency is easy, factual is engineered. Instead of isolated model, we use RAG to connect the LLM, large language model, to live cast data. Now every answer is grounded, every number is cross-checked, governance is proven from data source to final output. We are no longer talking about AI can generate answers. So we are talking about AI that must be trusted. So a standard LLM fails in enterprise analytic, not rarely, not only in special cases, they fail surely. And the reason is simple, they are statistically illiterate. They cannot run prog SQL, they cannot run prog means, they cannot verify numerical claims against your cast data. And that leads directly to the next issue, error rates. Unvalidated Gen AI creates 80% error rates on numerical claims. So even the output looks professional, no auditable trials, no role-based cross-control, no lineage from the data to answer. In enterprise environment, that alone is unacceptable. These models are trained on past data, not your live cast data. not your latest business context. So when you put in all together, the failure comes down to four things. They cannot validate numbers. They produce unacceptable error rates. They lack governance, and they do not know your current data. Now look at the right side. This is what happened when we fixed that. With SAS Voya as a statistical foundation, we achieve 85 to 99% efficiency. Sorry. So hallucination rate below 2% and about 71% reduction in cost. And there is the key message. 3 results are not coming from the model. They are coming from the architecture. So you must remember the architecture is very important. SAS provides the ground truth. GenAI provides the narrative, and then have we move from AI that it sounds right to AI that is right. This is the architecture. If you're looking at this one, this is the architecture that turns AI from something interesting into something you can actually trust. And I want you to keep one idea in mind as we go through this. Everything it says must come from the brain and must be verified by brain. So let's talk about the layers. Layer 1, SAS Voya. So remember, the SAS Voya is the foundation, the brain of the system. It holds your CAS tables, your computes, your metadata, and most importantly, your governance. This is your single source of truth. Every number, every fact, every decision must originate from here. So layer 2, integration. So think of this as your nervous system. So this is where we connect the brain to the mouse through RAG pipeline. And we retrieve the exact verified data needed for a question. But not everything, just the right context. So instead of the model guessing, we are guiding it with the truth. So layer 3 is foundation. So this is the mouth. This is where modules like GPT, Claude, or Llama operates. They take the verified content and transform it into human language. Clear explanation, summarize, insight, but again, they are not thinking independently. They are communicating with the system already knows. And then the most important layer is validation. So this is where the trust enforced. Every output generated by the model is sent back to SAS for validation. As statistical checks, self-verification, every agreement across models is needed. Nothing reaches the end user unless it has been exactly proven. So when you look at this entire system, this is not just AI. This is control, governed pipeline. From data to context, to communication, to validation, to trust insight. So let's look at how we actually ground AI in SAS data. Now that we have seen the architecture, this is where RAG, retrieval augmented generation based, becomes critical. Because without RAG, the model guesses. With RAG, the model is guided by verified data. This process happens 3 phases. Phase 1, indexing. We talk SAS data. We take SAS data and make it searchable. This means breaking it into meaningful chunks, aligned with SAS variable and metadata, not just raw text. Then we convert it into embedding and store it in a vector database. And so now, instead of scanning entire database, we can retrieve exactly what we need. Phase 2, hybrid retrieval. This is where precision comes in. We combine dense search with a keyboard-based search to ensure both semantic understanding and exact matching. Then we re-rank results, narrowing from many possibilities down to the most relevant, highest quality context. And importantly, we preserve SAS structure. We do not lose variables, names, or definitions. Phase 3, that's grounded generation. Now, the model creates the answer using only verified retrieved context with citation. Then all numerical results are checked again in SAS. So the model is not guessing, it is explaining validated facts. Why does this matter for enterprise SAS? RAG help us avoid tuning on sensitive data. Use live cast data in real time. Preserve governance and access control. Meaningful lineage from data to output, and it works across SAS assets. Cast tables, reports, code, metadata, and models. So instead of isolated AI tools, we can turn the SAS ecosystem into a searchable, governed knowledge level. That is the shift. So the shift is from AI generation to AI retrieving, validation, and explaining the truth. This is really about one simple idea. Enterprise AI is not just a model. It is fully operating system. Many people think success with AI comes from choosing ChatGPT, Claude, or another model. This is only one small piece. The real value comes from the stack around the model. At the bottom of this stack, SAS file, this is where trusted data lives. This is where trusted data lives, and your analytics, governance, security, and compute environment are all here. So as I mentioned, think of SAS file as the brain. Next, connect SAS to modern AI tools like using Python bridge like SWOT and SASPy. This let us combine enterprise analytics with today's AI ecosystem. Then we choose the model layer. Then we choose like the model can be commercial like ChatGPT or Claude, or provide open sources model like Llama running on the sensitive environment. To make this model accurate, we can embed it and vector database. So the key takeaway is this. The model creates language, but the system creates trust. And in enterprise AI, trust is where matters the most. This slide shows a very simple but important idea. If you want trustworthy AI, you need more than just a model. Many companies use AI tools and expect accurate answers automatically. Without controls, AI can make things up, given confident but wrong answers. As I mentioned, the error rate can be 18%. So what this slide shows is how we can reduce the error rates from 18% to 2% using the 3-layer framework. The first layer is SAS file, data governance. This is the foundation. It checks the numbers against trusted company data and validates. calculation. So before an answer is derived, the facts are confirmed. I'm sorry, I have allergy and sometimes I start coughing, so I hope it's not bothering you. So the second layer is RAG and workflow controls. This gives the model the right internal documents, tables, and business context. Instead of guessing, the AI works from approved and relevant information. And the third layer is LLM narratives. So this is like where models like ChatGPT creates the final reports in natural language. They turn validation data into summarized reports and clear explanation. So the pyramid matters because trust is built from bottom up. First, verified data. Second, correct context. Third, clear communication. If you skip the bottom layer, then the output may sound smart, but may not be right. So the model writes the answer. The system makes the answer trustworthy. Up to now, we talk about how to build AI. This is a slide about how to run it safely in production. And the key idea is simple. AI must be treated like software, not like a tool. First, prompt engineering. Prompts are not just text. They are code. They are tested, monitored, and improved. We run regression tests, enforce consistency, and validate changes before deployment. This gives us the control over how the system behaves, not just what it produces. Second, governance and compliance. We enforce PII masking before any external LLM calls. So we maintain full audit trails and apply rule-based access control. So maybe one of you can ask, what is the PII? That's personal information identifier. And when you give the information, the personal information like social security, your number or things is gonna be masked before any external LLM calls. So we maintain full audit trials and apply role-based access control. So every output is traceable, every decision is auditable, and the third is the cost engineering. AI is powerful, but it can be very expensive. So we design it for efficiency. So as you remember, if you know that design is very important because that can affect the cost. We use a smart caching, the right model for each task, a smaller context, and on-site deployment when needed. This allows us to scale without losing control of the cost. And the results are real. We reduce monthly LLM spend from $180,000 to $50,000. Wow, 71% reduction in cost. With no drop in user satisfaction, there is no optimization, there is no architecture. So this is architecture. So the reason right architecture can help you with reduced costs. And that's the difference between using AI and operating AI as a system. So let's move from architecture to impact, because none of this matters unless it creates real business value. Across industries, we see the same pattern. In financial service, analysts were spending over 25 hours a week writing compliance report. With this system, that dropped to only 3 hours. And 88%, so this is 88% reduction. In healthcare, ad hoc queries once took 2 or 3 days. Now they are answering under 2 minutes. So the results are clear. Efficiency gained from 85% to 99%. Accuracy above 99%. error rates below 2%, 71% lower operating costs. This is not a small improvement. I think this is transformation. And it happens because every output is governed. AI that is fast, accurate, and accountable. If you remember one thing, math has to be the anchor. So this slide is about being realistic, about where enterprise AI stands today and where it is going next. First, the limitation. I know you all know about some limitation when you use AI. AI is improving quickly, but is not perfect. For example, image and chart outputs still require human review because they cannot always be fully validated against trusted SaaS results. Agent-based system can also become inefficient in long workflows, so they need control and human oversight. Private on-premises model help with cost and data privacy, but they may still lag behind leading models on complex reasoning tasks. And in real-time environment, keeping RAG system updated continuously can introduce small delays. Now, the future direction is very exciting, I think. We are moving toward AI systems that can automate full workflows, planning tasks, writing codes, running procedures, and driving validated reports. We also expect multi-modal AI that can understand dashboard, interpret charts, and explain trends in natural language. RAG will allow organizations to query sensitive data across multiple institutions without moving the data itself. And AI Copilot will help analytics interpret machine learning languages result, recommend improvements, and generate explainable reports. Today, AI is powerful, but it still is improving. Tomorrow, AI will be more independent, easier to understand, and more built into business decisions. So I'm going to show you a demo, the real demo. So here, let's move from theory to reality. What I'm going to show you here is real clinical use case. This is based on the CDC clinical trial database with 254 subjects and multiple SDTM and ADAMS domains. And the goal is simple. Compare what happens when you use an isolated LM versus fully governed SaaS-based Gen AI framework. And as a reminder, this system has 4 layers: SAS via RAG for context, LLM for narratives, and validation for ensure the correction. Okay, now look at the actual question. So the question is, what is the mean duration of adverse events by severity? So this is not a simple question, actually, when I picked the question. Why is not simple? Because it requires calculating a derived variable, grouping by severity, running a statistical aggregation. So in other words, this is something that requires real compliance. And we already know the ground truth, so we can objectively evaluate accuracy. It's very interesting. You can compare the two sides. That was, the left side is when using the isolated LLM calls, and the right side then is using the framework we're talking about. So as you see, it couldn't get the result. And if you're looking at the bottom, the time, they use the same time to getting the result. So the left side, no tools, no RAG, no validation. And look at what happened. The model cannot compute the answer. It doesn't run queries. It doesn't execute logic. It can only describe the data. And worse, there is no verification, no audit trial, and very high token cost. It used 41,000 tokens just to fail. Now compare that with the framework, with RAG, SAS execution and validation. The system retrieves the correct variables, runs the computation in SAS, and generate verified answers. And notice, same question, same time, but completely different outcome. Now, let's look at accuracy. The framework result matched the ground truth. Within less than 0.2%, that is essentially perfect accuracy. This is not approximation. This is a statistically validated output, and that's the key difference. We are no longer guessing. We are computing and verifying. So now let's talk about the efficiency. First, token usage. We reduced token by 91% from over 41,000 to just around 3,400. That's not just performance, that's cost reduction at scale. Second, audit trial. Every step is traceable. RAG retrieves the exact variable. SAS execute the computation. Validation confirms the result. So now every answer has full lineage from data to output. So this is regulatory grade AI. So let me summarize what this demonstrates. First, isolated LLM are statistically illiterate. Without access to SAS, they cannot compare or verify anything. Second, this framework achieves over 99% accuracy. Every number is validated against real data. Third, we are reduced the token by 91%. And fourth, we achieve for auditability. So even every answer is traceable. So this is the difference between a model that talks about the data and system that actually understand it. Let me leave you with 3 principles. Math is the anchor. Generative AI can tell the story, but SAS provides the proof. Every number must be traceable. Every result must be verified, because in enterprise system, this is not enough. Second, governance is non-negotiable. Audit, trust, access control, compliance. These are not features you add later. They must be built in from day one, because without governance, there is no trust. And third, efficiency is engineered. You do not have to choose between speed and accuracy. With the right architecture, you can achieve both: high efficiency, high accuracy, high cost. At the same time, that leads to the real conclusion. We are moving beyond the novelty of the AI that can simply talk. The real value, the real impact comes from building AI that can be trusted. So I leave you with one question. When you look at how AI is used in your organization, is it built on mathematical proof or is it built on convincing sounding answer? Because the answer to this question changes everything. So before I leave, I wanted to make this practical. These are the 3 steps you can take immediately, not next quarter, not next year, this week. First, audit for mathematical drift. The number becomes your baseline. Second, integrated cast tables into RAG. Start with one high-value data set. Build a metadata over like retrieval layers and test natural language queries against it. Third, validate before you scale. Implement the 3 layers validation framework. SAS verifies the numbers, the model performance, and high-risk output go through a second review. Do not move to production until your hallucination rate is below 2%. This is your path forward. Measure, ground, validate. And if you follow these 3 steps, you won't just be using AI. You will be building AI that you can trust. I look forward to your questions, and I love to hear your views on how AI is heading next. So please reach out to me after the session or via email. I will be happy to answer any emails.